Right. We're going to look at how periodic functions behave when we change what we call the parameters of the function. So the parameters are these values a, b, and c if we write the periodic function like this. Just notice that if you set a to 1 and b to 1 and d equal to 0, we simply get sine to x. So that's the simplest form of the sine function that you can have. And we'll have a look at what that looks like in GeoGebra. In GeoGebra, we want to type this in. Whenever you want to type in a function, if you put a colon like this, you can display the graph straight away. We want to put in a multiplied with sine to b x, or multiplied with x. And we also want to put in a degree sign here. You can do that by pressing Alt O. So Alt O gives you the degree sign. And we add a D at the end here. Notice that this is an f of x function. So x is the variable. So GeoGebra is not going to treat a, b, and d as variables. So these are simply parameters. So values that we can change. And when I press enter here, I get a slider for each of the parameters a, b, and d. So let's set this one to 0, and the other ones should be set at 1. Now, this looks like a straight line, and the reason for that is the values are a bit low. If I change this, you can see that, okay, we get a nice sine curve here. The pattern starts here, and then it starts a new cycle about here. And you can see the value of that point is 360 degrees. So that's one period of the cycle. Yeah. Now, what happens if I change the a parameter of the function? Well, I could change it to 0. And you can see, okay, that gives us a straight line. But the a parameter changes the amplitude of the function. So if I go below 0, it increases. If I go above 0, the amplitude also increases. Notice that the amplitude is identical to the a value. So when a is 4, the amplitude is also 4, because the amplitude is the distance, the vertical distance from a maximum point to the main axis, right? So we could write that the a parameter changes the amplitude of the function. So let's see what happens when we change the b parameter. So the b parameter, let's just set this back to 1. I change the b parameter. Something happens to how stretched out the function is. Notice that the x values are the same, but what changes here is the period. So the period changes. If I change this to 2, so we have a b value of 2, you can see that, okay, we have to move 2 periods to get to 360. So it's sort of it's a multiple of the number of periods you can get within 360 degrees or within a full circle. If I set this to 3, I get 3 periods within. So we could write then that the the b parameter changes the period length of the function. What happens if we change the d parameter? So this shifts the whole function vertically, and it shifts this this axis that we've been talking about before. So we can write that let's paste this in. The d parameter shifts the principal axis of the function vertically. Let's look at one example at how we can predict the behavior of the graph of a sinusoid function. So here we have a cosine function with the parameters a, b, and d, and I've set these parameters to -20 for a, 3 for b, and 0 for d. And if I draw that, it's going to look like this, and this is the function -20 multiplied with cosine to 3x. And what we can notice then is, okay, we have an amplitude of 20 because the principal axis goes through the x-axis. So we have a minimum value of -20 and max value of 20. So that's the amplitude. And we have 3 inside the parenthesis here, so cosine to 3x, which means that there are 3 periods in a 360-degree cycle. So from 0 to 360, there are 3 periods. So to find the period length, we could divide 360 by 3. So the period is 120 degrees. So for every 120 degrees, we have a new period, which is at this point, from here to here. This is the cosine function, so that's why it doesn't start at 0. So it starts at -20 here, and then we have 1 period for every bottom here.